So in example 88, let's see, so we already read it. So I wrote down that I have a simple random sample of 200 children, so that's my sample size. Now the only other thing in here is it tells me 70% of children in this city go door to door for trick or treat. So does that sound like it's a population percentage or a sample percentage?
They gave us the percentage.
Yes.
Right? So it's population.
That's what I would.
They would turn it off.
That's how I would.
Okay, so you guys say that it's the population percentage? Is that what you're saying?
Yes.
Okay, and I would agree. One of the things that I've noticed over the years is it talks about this is the percentage, and then afterwards it's telling us we took a random sample. Okay. If it was going to be a sample percentage, it would have said we took a sample of 200 children and found that 70%. Okay, but in this it's kind of obvious that that wasn't referring to the actual sample, and so that leaves it to be the population percentage. Plus, it's saying in this city 70% of all the children. It didn't say the word all, but it's kind of implied there of this is for the entire city. So I would agree that that is a population percentage. So because I know my population percentage, we're obviously going to have to be going from the population to the sample. So now this goes back to chapter 20. And so I know we did chapter 20 problems on Monday, but it's always good to have the review and to see kind of the difference between the two chapters. So number 2 says, what is the chance that less than 65% of them go door to door for trick or treat? And when we say them, we mean children in the sample.
Kaysville called and their network is dead down there, so they can't. They did connect, but then they lost it. It's all gone black.
Okay.
So they're not here anymore.
Okay. So it sounds like Kaysville is not going to be joining us for tonight. Russ, I am going to record it and then I'll put it up there tonight, so I don't know if you want to tell the people down in Kaysville or not, if that will affect them.
All right.
Okay, so back to our problem. We're looking for a chance. And also, as soon as you see this and you're talking about kind of your percentages and populations and samples and things, the chances, the only time we did chances was in chapter 20. So that would be another clue that we're doing chapter 20 things. But also, as soon as you see chance, you should know that you're going to have to use the normal curve. Because that's the only way we've learned how to do chances for things like this with percentages and populations and samples. And so if you go to your memory aids, or first of all, anytime you use the normal curve, you need to find a z-value, right? So if you go to your memory aids, look for a z-formula. There's 3 z-formulas. There's one for sums, one for percentages, and one for averages. At this point, it should be fairly obvious that you want the one with percentages, since you know you're working with percentages. So z is going to be your percentage minus the expected value of the percentage over the standard error of the percentage. Let's see, so I guess I need to go and find some of those things, right? So the expected value for your percentage, that's equal to your population percentage. My population percentage was 70%. And the standard error for your percentage is equal to the square root of your population percentage times 100 minus your population percentage over the sample size. Now in this situation, we actually do know the population percentage. I can figure this out exactly. So my population percentage is 70 times 100 minus 70. Over my sample size, oh, how many people did we look at? 200 people. So this gives me 3.24%. So make sure you can get that 3.24%. So now back to our Z. Z is the percentage minus the expected value over the standard error. The percentage is the one that you're interested in for this problem, so we're specifically interested in the chance that less than 65%. So it's going to be 65 minus my expected value of 70 over the standard error of 3.24. So negative 1.54.
Can you tell me one more time how we knew which Z formula to use? Because I'm confused on using like the sample percentage plus or minus, and then that one.
You mean, so you're confused between this one and this one?
Yeah, like how did we, because I'm just stuck on the estimate one, I guess. Is that the one that we use for different things?
Yes. So we do, yeah, we will use them for different things. This first one is you're going to use it whenever it says find the chance or probability.
Oh, okay. So.
And this one will always be confidence intervals.
Confidence. Okay, thank you.
Okay. Plus, when you're looking for a chance in a normal curve, you know you have to kind of like find Z, and this is the formula that says Z equals, so that's the one where you'd be using it to find Z, if that helps. Let's see, so we calculated Z. Z is negative 1.54. So here Z equals negative 1.54. And then which direction do we shade? So what's the chance that less of them? So we're going to shade to the left. Now sometimes, and especially later on in this course, once we start doing hypothesis testing, it's tempting to just always shade the small tail, because it seems like that's usually what happens, but it's not always. Sometimes you get a situation where it's not the small tail, but it's the bigger half, I guess, if you will. And so always pay attention to your keywords to see which direction to shade. So this was less than 65%, so we shaded to the left. Okay, so let's open up our normal table. We're looking for negative 1.54. Looks like the closest I can come is this negative 1.55, so the area to the left is 6.06%. So that is my final answer that I was looking for. So that's how you find a chance. And once again, when you start seeing these things with like populations and samples, this is the only way we know of to find the chances. So let's do a little interpretation of everything that we learned in this problem. So first, for the expected value and standard error, I could say, so if I take a sample of 200 children, I expect to find about 70% trick or treat, give or take 3.24%. So that's what your expected value and standard error tell you. So when I go take the sample, I haven't taken the sample yet, but when I do, I expect to find that about 70% trick or treat, give or take about 3.24%. And then I can be more specific if I want and go find specific chances. So we're interested in what's the chance that less than 65% go trick or treating. And so I can say I found that, so there's a 6.06% chance that less than 65% of children in the sample go trick-or-treating. how do you feel about this problem? Okay, and then number 3, do I need to be told that the children follow the normal curve? So this comes down to the fact that you can only use the normal curve to find chances for sums, percentages, or averages, okay, if you have a large sample size or the individual data is normally distributed. And we're actually going to use this fact out the entire semester, so we use it in chapter 20 when we're looking for chances. We kind of use it in another form without utilizing it when we do confidence intervals, and we'll also do the same thing when we do hypothesis tests. So once again, you can only use the normal curve for your sums, percentages, or averages, depending on what you're working with, if you have a large sample size or the individual data is normally distributed. Now in our situation, we have a sample size. Our sample size is 200. So that's very large. So we can use the normal curve
I have a question.
Okay.
I seem to remember that you said that like 4 to 500 is large. And so I'm just like, where do you draw the parameters on large and not large?
Okay. Just a sec.
Is it just over 30?
So there's different rules of thumbs for what you're working with. So for chapter, what did I put in? Chapter 20, 21 maybe? So for percentages, what you actually have to check for percentages is you have to check the population percentage times 100% minus your population percentage is at least 1,000. That's what you have to check for averages. And, wait, no, that's not what you check. Sorry. Gone to star standard there. You have to check that your population percentage times the sample size is at least 1,000. And that your population percent times 100 minus the sample size. Sorry, I'm having a really hard time writing this because I keep thinking ahead. But you also have to check 100 times the population percentage minus the population percentage times the sample size is at least 1,000. And that's for percentages. For averages, it just has to be that your sample size is at least 30. So that's why you're thinking of the number 30, is because I might mention it somewhere for your sample, for averages. And yeah, it would be the same for sums. Okay. For percentages, though, it does have the complicated thing to check, and I told you I'm not going to make you check it for this class. So we've kind of just said if it sounds like a big number, it's probably big enough for the percentages. So we did one problem where it was like 500 and another one was 400. So that's where you're thinking of those numbers. But 200 is still a big number, and so I feel fairly safe in this situation. But we don't have, I'm not making you check for a specific number in this class for percentages. Once we get to the averages, I'll make you be a little more specific, but for percentages, it just takes too long to check.
Okay, thank you.
So once again, since our sample size is large, we can use the normal curve even if the data isn't normal. So no, we didn't need to be told that it followed the normal curve. Now this next example is suppose we toss a third coin 500 times. Now technically we did this problem on Monday, right? So I'm not going to do it again. I'll wait until the end of class and then do it again if you guys want me to. But I will just skim through it. So it just says suppose we toss a third coin 500 times. So this one's slightly harder for you because it doesn't actually talk about the percentage, so you might not recognize it right away. But it is saying like percentages, so you know you're talking about percentages, and then find the probability that we get more than 53% heads. As soon as you see this, you know that that's asking for the chance, which means you have to use the normal curve. And you're going to need to use that Z formula of percentage minus expected value percent over standard error percent. So as soon as I see that, I realize, oh, this is dealing with chapter 20. Also, it doesn't ask me to find the confidence interval, which is the kind of giveaway that it's not chapter 21. Okay, whereas example 90, so let's go through and make sure that we can pick out which chapter it comes from. The Department of Education reports that 80% of students nationwide. 80% of students nationwide without even reading the rest of it. That sounds like that would have to be a population percentage if it's nationwide, right? And so this would be my population percentage equals 80%. And then we decide to take a sample of 600 students and ask them, so I have my sample size equals 600. Notice, just look at the way it's worded. We're deciding to take a sample. It didn't take a sample and give us results. So obviously this is one where we have the population percentage and we're trying to figure out what will happen when I take the sample. And so this one would have to be population to sample for chapter 20. That's kind of how I distinguish when I'm doing these problems, since I know the hardest part is figuring out what formulas you're supposed to be using. Also, like, what's the probability? And so then I know I need to use the normal curve. I need to use that Z formula. Okay, so think of the last problem. Now compare it to this example 91. So in a simple random sample of 500 USU students, 372 of them voted for Romney. Notice it's in the sample of 500 students, 372 voted for Romney. So that means obviously those numbers are for the sample. So I have my sample size equals 500. And then it didn't say the word percentage yet, but if I keep going, find a 90% confidence interval for the percentage. So obviously I'm dealing with percentages and not sums or averages yet. So we said that this number of 372, that's for my sample. So let's find my sample percentage. So 372 divided by 500 equals 0.744, but I remind myself, oh, it's supposed to be a percentage, so I times it by 100% to get the actual percentage. So it's 74.4%. That's my sample percentage. So I know my sample percentage, so this would be one where we're going from our sample to our population, which means it's going to be from chapter 21. Also, as I keep reading it, find a 90% confidence interval. As soon as I see confidence interval, I know that it's going to be chapter 21, and also coming back to my memory aids, because it's a confidence interval, I know I'm going to be using this formula with my estimate plus or minus. Specifically because it said confidence interval, I know that confidence intervals have the plus or minus in them. And what else was I going to point out? Find the confidence interval for the percentage of all USU students. So that says I'm trying to find out information about my population. So that's another way I know that I'm going from sample to population. So we want to find our confidence interval. So first, let's estimate, because it didn't tell me the steps, so let's just go through. Let's estimate my population percentage. So my estimate for my population percentage would be what?
Same as sample.
Okay, same as your sample, right? That's your best estimate. Then find your standard error. And the formula for standard error is population percent times 100 minus your population percent over the sample size. Now, do we know the population percentage to plug into this formula?
You have to use your estimate.
Okay, I have to use my estimate, so I'm just going to do little curvy equals to remind myself that I'm just estimating that. And we'll use our sample percentage, which was our estimate. So 74.4 times 100 minus 74.4 over my sample size, which was 500. So 1.95%. And then for your confidence interval, the formula on our cheat sheet is estimate plus or minus our critical point Z star times the standard error. Now specifically for percentages, our estimate is our sample percentage plus or minus Z star times the standard error for your percentage. Okay, so our estimate or our sample percentage was 74.4 plus or minus Z star. Now we didn't find Z star yet. We should go find Z star. To find Z star, I said we wanted a 90% confidence interval. So you put 90% in the middle. And then you ask yourself, okay, if there's 90% in the middle, how much is going to go in each tail?
It's a 1.65 z-squared.
Okay, it is 1.65. And so did you figure that out quickly, or did you remember that?
I memorized it.
Memorize that? And that is just fine. Okay, because there are the 3 levels we use often, and you can memorize them if you want. If you didn't have it memorized, you say, okay, 90%, that's 10% left over, 5% for each tail. And then I'd go to the table and either look up 5% or look up 95%. But Z is 1.65. Okay, so my critical point Z star is 1.65 and my standard error is 1.95. Let's see, so 74.4 minus 1.65 times 1.95. It's 71.18% to 76.61% or 62%. And this means that we are 90% confident that the percentage of all USU students that voted for Romney is between 71.18 and 76.62%. And that's how you would interpret that. So we don't know for sure, but we're 90% confident that the population percentage is between those 2 numbers. Let's see, so that was a sample of 500 students. Now this next one, it says we have a simple random sample of 20 USU students and 7 of them voted for Romney in the 2012 election. Why is it not a good idea to use this sample to find a 90% confidence interval for the percentage of all USU students who voted for Romney in the 2012 election? Okay, so this is a multiple choice of why is it not a good idea to use this sample. So first of all, before you look at the choices, what would you tell me about maybe why I shouldn't use this sample?
Sample size is tiny.
My sample size is tiny, right? And so 20, I mean, without even looking at our exact numbers, 500 is obviously big, 20 seems very small, right? So the sample size is small, so we can't use the normal curve. Okay, this is correct. Let's go ahead and look at the rest though, just in case it wasn't all of the above. The next one says the sample size is small, so it has no information about the population. Okay. Well, false. It is small, but it has a little info about the population. I mean, it doesn't have a lot of information because it's small, but it has a little bit. And number 3 says the sample size is small, so we can't calculate the sample percentage. This is absolutely false. It doesn't matter how big your sample is, you can still calculate the sample percentage. Sample percentage is 7 out of 20 and times it by 100%, which is 35%. So it doesn't matter how big your sample is, you can still calculate the sample percentage. But if your sample isn't big enough, then you can't use the normal curve. And we use the normal curve to find that z-star value. So any questions on what we've done tonight?
Logan has come to the consensus that we have no questions.
Okay, so then at this point we can do a couple things. So you could ask me questions about the homework, or like we can go back and do those 2 pages, redo those 2 pages that we did on Monday. Or I can make up some more problems for the percentages if you guys want me to just make them up so that you can practice. What are you guys feeling like? Do you want some more practice for this chapter 20 and 21? Or how about we do it this way? If you want me to make up problems for chapters 20 and 21, go ahead and raise your hand and I will try and see you on the screen. So there are at least a couple people. So I'm going to make up a couple problems for these percentages. Okay, and since we are so early, I don't think I will technically dismiss class yet. We'll just keep going. Let's see how well I can make up problems on the fly. So let's say, so made a problem 1. Let's say that 76% of people in Utah floss their teeth. Okay. If I take a sample of 250 people, let's see, what is the chance that more than 80% floss their teeth? So first of all, when you look at this problem, is this going to be a chapter 20 or chapter 21? Like, do I know information about the population or do I know information about the sample?
Population and chapter 20.
Okay, so we know information about the population because my population percentage is 76%. So we're going from population to sample, so chapter 20. And we can also write down that my sample size equals 250. So I know I'm going from population to sample. Let's see. Oh, we want to find what is the chance. Now you might have noticed on all of these problems we kind of have to do like our either estimating or doing expected value and standard error. But if you forget that, you say, okay, chance, I know it's the normal curve, I know I have to find z. Every time it's looking for chance, you have to find z. So we know z is going to be my percentage minus the expected value for the percentage over standard error of the percentage. And just by writing that down, now I can figure out, okay, what intermediate steps I need to do. Let's find everything we need to plug into here. So the expected value for my percentage, that's just equal to your population percentage, which we said is 76%. And the standard error for your percentage is the square root of your population percent times 100 minus your population percent over 250. Oh, sorry, over your sample size. So my population percent is 76 times 100 minus 76, all over 250. So go ahead and double check all my calculations as we do these made up problems, since I haven't done them before to double check myself. I get that my standard error is 2.7%. Now let's find z. Z is your percentage minus expected value over standard error. The percentage we're interested in is we're looking for the chance that more than 80% floss their teeth. So the percentage of interest is 80, the expected value is 76, the standard error is 2.7. So Z is 1.48. So I always draw a pretty picture. Now, which direction do I want to shade and why?
Can you scroll back up?
Yes.
To the right.
To the right? Because
Oh, because it
Because
says
you're
more.
asking for more than.
okay, because I did ask for more then, yes. That's okay. I always appreciate when I have participation. So it's a good thing. It just means we have extra participation. Okay, so we want the area to the right, so let's go to our normal table. Z is 1.48. Looks like the closest one is this 1.50, so it has an area of 93.32. But that is the area to the left. I want the area to the right. So 100% minus 93.32% gives me 6.68%. So that was our final answer for what they actually asked. Now let's kind of interpret, write down the different things they told me, or the different things we found. So if I take a sample of, how many did I say? 250? 250 people, I expect to get about, I can't even see, 76% that brush their teeth, give or take 6.68%. And that's your expected value in standard error. Now you can be more specific, and so like even more specifically, there is a 6.68% chance that more than, what did we find, 80%? Yeah. More than 80% in the sample brush their teeth. Oh wait, sorry. What did I do wrong here? This is what happens when you're zoomed out too far. Give or take how much? We expect 76% to brush their teeth, give or take how much? What should be my give or take amount?
What do you mean?
2.7 plus the minus percent.
I'm gonna be the one first one.
I was 1.48, but.
Okay. The give or take amount is always your standard error, right? So for everything we've done, the give or take amount is always the standard error. So it should be give or take 2.7%. So standard error is the give or take. Sorry, it's a little bit harder when you don't have, when you can't see everything together, isn't it? So we made up that problem. Okay, I'll post this on Canvas too if you weren't writing fast enough to get it all for your notes if you want it in your notes. So let's make up another problem now. So made up problem 2. Let's say we took a sample of 157 USU students, and $110 of them brush their teeth. For A, let's estimate the percentage of all USU students that brush their teeth. And B, let's find a 99% confidence interval for all USU students that brush their teeth. So I've been trying as we go through these problems at the beginning to start kind of telling you what I'm thinking as I'm seeing the problems and kind of like how I'm figuring out what I need to do. So you guys go ahead as you look at this problem. What are you seeing when you look at this problem? What are your first thoughts? Okay, it is the sample because it's a sample of 157 students and 110 of the people in the sample brush their teeth, right? So this would have to be a sample to a percentage problem. So that's chapter 21. Plus it says finding confidence interval, and that obviously happens when we go from sample to percentage. Let's write down the info we have. My sample size equals 157, and my sample percentage is going to be 110 out of 157, and I need to times it by 100%. Remember, anytime you're looking for a percentage, you have to always times by 100. So you do the division and then you times by 100. So this is 70.06%. So for A, estimate the percentage of all USU students. So our estimate of all USU students is 70.06%. But I'm not going to be content to stop there. I'm also going to want to find my standard error. The standard error for my percentage is the square root of your population percent times 100 minus the population percent over the sample size. Now I don't know the population percentage. I have to estimate it, so let's do our estimate here. So we're going to use our sample percentage of 70.06 times 100 minus 70.06 over my sample size of 157. So practice putting this in your calculator. Make sure you can get the same thing as me. Make sure I'm getting the correct thing. So I got 3.65%. Someone else go ahead and either tell me they got something different or back me up. Anyone? Did anyone else put this in their calculator?
I got 3.65 as well.
Okay, you got 3.65 as well. So that tells me that my estimate is likely off by about 3.65%. So my estimate for all the USU students is 70.06, but my estimate is likely off by about 3.65. Now B, find the, what did I say, 99% confidence interval.
I have that memorized too. It's 2.60.
2.60? Okay. So that is correct. I'm going to go ahead and find it just in case someone else doesn't want to memorize it. So if it's 99% in the middle, then that leaves us 1% for each tail. And divide that by 2 leaves us 0.5% for each tail. When you're done, add them back up and make sure they all add up to 100. That's a good way to double check. So we're looking for this C value. Now I'm going to look up just 0.5% and find this number here because that's a little bit easier to do. So go to your normal table, look up 0.5%. The closest one is this negative 2.60. So this is negative 2.60. So the positive one is positive 2.60. So my confidence interval is going to be sample percentage plus or minus Z star times the standard error for my percentage. My sample percentage was 70.06 plus or minus Z star, which is 2.60, times the standard error of 3.65%. Okay, this time I'm going to go ahead and do the multiplication first, just in case that's the way you like to do it. So 2.6 times 3.65 is 9.49. Okay, so now I'll do 70.06 minus 9.49. That gives me 60.57 to, and if I do the add, 79.55. And the most important part is, can you interpret this correctly? So we are 99% confident that the percentage of all USU students that brush their teeth is between 60.57% and 79.55%. And I certainly hope that it is something much higher than this one I made up. Now that's your interpretation. Now let's go ahead, since we're just making stuff up, let's go ahead and talk a little bit more about what does the 99% confidence level mean. So do you guys, anyone want to take a stab at this? Anyone remember what it means from the video?
It means that of all possible confidence intervals, about 99% will contain the true population percentage.
Perfect. So of all the possible confidence intervals, about 99% would contain the true population percentage. So someone tell me why, well, it says all possible confidence intervals, why is there more than one confidence interval? What does that mean of all the possible confidence intervals? Why is there more than one? Anyone want to take a stab at that? is because for every different sample that I could take, I would get a different sample percentage and hence a different confidence interval. So that's why there's lots of possible confidence intervals, because there's lots of different samples you could take. Let's see. Well, we're still making stuff up. Or making up questions, I guess. We're not making up stuff that we're writing down. Is there any way to tell if our confidence interval contains the true population percentage? So Amanda shakes her head, no. So we know that 95% of all the possible, or 99% of all the possible confidence intervals contain the true population percentage. But there's no way to tell if the one that we just found does. Which I know sometimes students find very frustrating, because they're like, well, I found it, so how do I know if it's correct or not? And the problem is, you don't know. We're just dealing with chances. And one final thing I want to say. So, you cannot say that there is a 99% chance that the population percentage is in our confidence interval of 60.57 to 79.55. You cannot say that. Why can you not say that? Does anyone remember from the video? It seems like a very intuitive thing to say, and people really want to say it, because we know that there's no way to tell if the interval contains a true value or not, and they want to at least put a chance on whether or not it contains a true value, but we can't say this. The reason why is that the true population percentage is fixed. It doesn't change. We just don't know what it is. So there is no chance associated with it. Now that might seem like a very nitpicky, small point, okay? But it is an important one to statisticians. Okay? It's also important that when you go out into the real world and you're interpreting things and giving real world reports, that you're not making some of these common misconceptions, because they do change things quite a bit. So any questions on what we've done here? Then at this point, I think we've made up sufficient problems, so I will stay, and you are welcome to ask any questions you have on the homework, or even ask me to make up more problems, whatever you want, but I will dismiss class and you can stay for questions. Make sure that you guys are bringing questions from your homework and utilizing this time.